Example C. We're going to solve for x. 3 multiplied by 2.1 to the x equals 53. Notice we cannot take the 3 multiplied by the 2.1 because the 2.1 is the only item raised to the x. So again, if I follow our 3 steps, step 1 was to isolate the exponential. Notice once again, the exponential is not isolated, and so the first thing I'm going to do is divide both sides by 3 to isolate the exponential piece. Doing so gives me 2.1 to the x equals 53 divided by 3. Now I'm going to take the logarithm of both sides, so I'll have the log of 2.1 to the x equals the log of 53.3. Now notice, this is the first one where the log and the base don't cancel out, and so I can't just remove the log and the base. So what I'm going to do is use one of my logarithm properties. I'm going to use the property that says the log of a to the p is equal to p log a. Doing this gives me that the log of 2.1 to the x would be the same as x log 2.1. So I end up with x log 2.1 equals the log, and that should be log, not natural log, of 53.3. So now if I do the math out, I'm going to get x equals, I'm going to divide by the log of 53.3 divided by the log of 2.1, and that gives us 3.871. It is important, unlike what I wrote on my paper, it is important for us to realize that we need to use the same kind of log. We could have used both the log, the common log, or we could use the natural log. As long as we're consistent within the problem, we can use either one. Again, you should go to your calculator, make sure that you can get the 3.871. Again, in the back of the book, they might actually write the log of 53 divided by 3 as the log of 53 minus the log of 3. Either way would be acceptable. When you put it in your calculator, either way you should get the same answer. Just be careful with your parentheses.